Hello everyone, today's objective is that after watching this video you should be able to solve a quadratic equation by completing the square method. Now typically you learn the factoring method first, but the reality is that some quadratic equations cannot be factored. Let's take this one for example. Let's say we've got x squared plus 8x minus 13 equals 0. So first thing, if we're factoring, we notice right away, all right, there's no number in front of the x squared. That's nice. I don't have to do the AC method. All I have to do is find two numbers that are going to multiply to negative 13 and add to 8. Now, there's other ways people express that. I've seen a way where there's some sort of x thing and you write stuff. I like to make it what I call the Ma table, is I'm like, all right, again, sometimes you can just do this in your head, but I want it to multiply to negative 13. I want it to add to 8. I'm like, all right, what are all the things that multiply to negative 13? Well, 13 is a prime number. So really, you got negative 1 and 13, and you got 1 and negative 13. This one adds to 12, I think. This one has a negative 12. None of those are 8. So that one cannot factor, actually, not factorable. Now, that's why I like the mod table, because if you list all the factors, you can be 100% sure, hey, it is not factorable. So how do we do this? That's the question. Now, before I solve this problem, I'm going to scroll down here a little bit. I'm going to show you this important formula, and then I'm going to prove the formula. So this formula that is basically based on the completing the square method is that x plus b over 2 squared is equal to x squared plus bx plus b over 2 squared. Okay, you might be thinking, well, why does that help me? Okay, so the idea is you want to get your equation to look like this, and then you can turn it into something like this. Now, I said I was going to prove the equation. Now, if you're bored by the proof, you can skip ahead a minute. That's okay. But if you want to understand why things are true, I'm not only going to prove this, I'm going to show an example, right? But let me prove this. If we're squaring something, right, that means multiplying it by itself. So x plus b over 2 squared is x plus b over 2 times x plus b over 2. So let's say, for example, I'm going to give an example. Okay. Let's say I had x squared plus 6x plus 9. Okay? Now, in this formula, I can see clearly that b is whatever is times the x. So b would be 6. b over 2 would be 3. Now, in this case, it turns out that if I do b over 2 squared, it is in fact 9. So this is an expression that fits this formula. So b over 2 is 3. Now I want to prove that x plus 3 squared is equal to that, right? So we're trying to prove this is equal to x plus 3 squared. So if I have x plus 3 times x plus 3, same process I'm going to do for both. That's why I've showed these side by side. So I FOIL it. FOIL. First term gives you x squared, like in this case, just x squared, right? Outer terms. So in this example, x times 3 is just 3x. And again, when I do inner term, I also get my plus 3x. I'm just going to finish the bottle example first. Then 3 times 3 gives you 9, so plus 9, right? So same sort of thing happens here, that your b, whatever your b over 2 value is, it multiplies by x. So plus b over 2x plus b over 2x. Plus, that's where we get this last term, b over 2 squared, from. Because guess what? These two are going to add together, x squared plus 6x plus 9. That's why we took this and divided it in 2 first, right? And sure enough, if I got b over 2 plus b over 2, imagine you got half a pi plus another half a pi. It equals a whole. Half of a b plus half of a b is a whole b. Okay? So, this is our formula. So that kind of proves it, so justifies, okay, it kind of makes sense that this formula is true. Now, when we solve these problems, we kind of go in reverse of what I just proved here. So I'm going to scroll on up here, okay? Keeping that formula in mind. In fact, why don't I just write it in red, okay? X squared plus bx plus, again, you're welcome to do this on your pages as you do that, plus b over 2 squared equals x plus b over 2 squared. Because some of you might still be wondering, well, how does that help me solve the problem? Just don't worry. Okay. First thing, if we're going to use this method, though, we actually want to get my other numbers to the other side. Now, I know our other methods for solving quadratic, we like it equal to 0. But let me just get this out of the way. So I've got x squared plus 8x. What I'm going to write this as plus 8x plus blank is equal to 13. Why did I say plus blank, right? Well, because I want to figure out what goes here that's going to make this a perfect square. Make sense? So if I'm looking at this form of the equation, whatever times x is your b, right? So I'm going to say, okay, well, b is 8. So b over 2 is 4. So b over 2 squared is 4 squared is 16. So I want 16 here. Now, I've got a problem. If I just write this formula, I broke one of the fundamental rules of algebra. Whatever you do to one side, you got to do to the other, just like I did here. So I'm going to add another plus 16 over on that side. Aha. So now I've got x squared plus 8x plus 16 equals, let's see, what is 13 plus 16? I'm pretty sure it's 29. You can check me if you got a calculator. Now, what that means, ding, 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 now that I'm in this form. So this polynomial right here is what we call a perfect square polynomial. That's just a math word that says, hey, it fits this formula, where this last term is b over 2 squared if the first term is b. That means this is the key step right here to the completing the square method, that I can turn it from this form to this form. B over 2 is 4, okay? B over 2 is 4. That's what goes in the parentheses. So I've got x plus 4 squared equals 29. Okay? Now, I know some of you are probably like, why is that any better? It still looks like an equation. I don't know what the answer is yet. Hold on. I've got a great key for you. Once you have something in this form, like it's something squared, you undo a square by taking a square root. Boom. Now it's no longer a quadratic equation. You're just going to basically have one x there that you can solve for. Let's delete that formula I had down there. I got it up here now. So when I take the square root, it makes the squared go away, right? But because the square root of something could be positive or negative, I've got x plus 4 equals square root of 29. Again, you can calculate the decimal version later if you want. Or x plus 4 equals negative square root of 29. Now, let me break down that step. Let me just kind of go over here and write another thing. Some of you are lost, like, what? Remember, if x squared equals 4, let's say. Again, I take the square root of both sides. X equals 2, right? Kind of make sense? However, notice that if I square negative 2, I also get 4. Right? So that means that when you do the square root, there's really two options. There's a positive version or there's a negative version. X equals 2 or x equals negative 2 would satisfy that equation. Same here. So I split it into two equations now. Okay? So both of these are solved by subtracting 4 from both sides. Now, you could say root 29 minus 4. There's just kind of a standard like math way that mathematicians like to write it. I just like doing the standard form, negative 4 plus root 29. Okay. Now, I would like to mention, if you put the decimal answer, so this one's negative 4 minus root 29. Okay. Now, if you put the decimal answer, again, depending on the maybe quiz or test you're doing, it might tell you to round or give the exact form. Sometimes mathematicians like the answer like this. It looks more complicated. Like if you're doing something practical, like building something or an engineer, you probably want a decimal approximation, right? You want to know if it's closer to like 10 or closer to 7, or if it's like 3.8 or something specific, right? You care about the actual number. Mathematician, this is exact form, right? Square root is exact. So another way you could write this, you could actually put both of these together and say what we call x equals negative 4 plus or minus root 29. So if you actually don't want to split it up, you could have actually basically gone straight here. I just wanted to show what that means. If you see a plus over a minus, it really means that there's two equations, right? It's either the plus version or it's the negative version, okay? But if we are doing a decimal approximation, square root of 29 comes out to approximately 5.38. So over here, let me kind of split it up again. So it would be like negative 4 plus 5.38, or x equals negative 4 minus 5.38. So if we do that, 5.38 plus the negative 4 is x equals 1.38. So again, if you're doing decimal approximation, that's that number. And then this one is negative 9.38. Boom. So those would be the two approximate solutions to the equation, whereas this would form the exact solution. Okay. So this is the exact solution. These are the decimal answers. So it just depends what form of the solution you want. So let's do one more example. All right, this example right here, x squared plus 6x minus 11. Okay, if you try to factor it, it won't factor. I'll tell you now. Now, another thing about completing a square, it's nice if the middle one is even, so I'm being nice to you guys. What I want you to do, go ahead and try this on your own first. Pause the video right now, and then check in, you'll see solution. Okay, you've done it? Okay, cool. Let's walk through the process. So b equals 6, so b over 2 equals 3. I'm going to go a little faster because you should at least have some work that already be done. b over 2 squared means 3 squared, which is 9, which means 9 is the thing that I want on both sides. Now, again, I first like to get in this form, just get the 11 out of there. So I've got x squared plus 6x plus blank equals 11. What do I want there? I want a plus 9, and really the plus 9's got to go on both sides, right? So now I've got x squared plus 6x plus 9 equals 20. Now, really nice, this example, I already kind of showed the factored form earlier. I showed that this is what becomes x plus 3 squared. Boom. Apply the formula, half of b is 3. X plus 3 squared equals 20. So I take a square root. Boom. X plus 3 equals. Now it equals the plus or minus root 20. Now, you don't have to do it this way, but I'm going to show how we would keep it together kind of as one equation. If I subtract 3 from both sides, this is why it's standard to kind of keep the square root second. So even though I'm subtracting, I just put a negative 3 in front, because then the plus or minus is an operation I'm doing from or to the negative 3. So negative 3 plus or minus root 20 is the exact answer. Now, I didn't tell you which one to find. So let's find both. So this is the exact answer. So if I want the decimal approximation though, I've got to plug that into a calculator. So I'm doing that right now. I've got the square root of 20, turns out is about 4.47. Let's do 2 decimal places. So if I do negative 3, I could kind of write it like this, negative 3 plus 4.47. And again, you don't have to write it down. You could just calculate it, right? But I'm just showing what we would do. Negative 3 minus 4.47. So again, use your handy dandy calculators and you should get 1.73 and negative 7.73. Boom. Again, I probably could have done that without a calculator. I paused and used a calculator. Embarrassing as a math teacher. But anyway, hopefully that makes sense. Hopefully you're looking at that like, yeah, I did it. Now, if you got the wrong answer, don't stress. It's like one of the first ones you try to do. It's all good. You got this. So I hope my prayer is after watching this video, now that you are confident that you can do that math, that now I can solve a quadratic by completing the square. Y'all have a wonderful day.